In strictly proper system, the first step is always the same. Alright, you determine your transfer function for your plant first. Alright, this is the plant. Alright, where your bs is your 1, as is s squared plus 2. Alright, and you determine your degree of freedom. I mean not degree of macam, your degree of your order of degree. So at this part over here, your bs has no order, so it's 0. For here is second order, and therefore it's 2. So your n is equals to 2. Same thing, since you know your n equals to 2, therefore the next step of you is to predict the number of polynomial you have for your controller, and therefore you put your 2 inside this criteria for strictly proper. Alright, for strictly proper stuff. Alright, this different from proper already. Alright, because strictly proper means that you're more strict. Alright, so you want things to be more stable. Macam only. Alright, so your degree of h is 2, while your degree of your g is 2 minus 1, which is equals to 1. Alright, so therefore for your h over here, which is the denominator one, you know that you must say that this is a monic system. Alright, so therefore it's a second order, so it's s squared plus h naught. I actually forget to tell you that you must say that it's a monic polynomial. Polynomial or something like that. And as for g is a first order, so it's some we know that the g isn't a monic one, so therefore it's just simply some g1 s plus g naught. Alright, actually this never mind. h1 s, hold on a while, because it's a second order, so I have to write h1s plus h2. Okay, so because it's second order, first order, zeroth order. Alright, this is the polynomial that we want. Okay, for your h, it's a monic. While this one is the first order because it's just s only. Alright, so be mindful of that. So I can say this whole thing is the second step. The third step is to just sub in my n over here. Where's my n? My n is 2, right? So 2 times 2 is 4. So my order of degree for my ACL, my Diophant equation must be 4. Okay, so therefore what I can do is to sub in my Diophant equation first. So it's just a naught h plus your b naught g is equals to your ACL closed loop. CL is closed loop. Alright, so your a naught is what? A naught is this dude over here, s squared plus 2. Same thing I sub in over here, s squared plus 2. What the hell is your h? Your h is now this one, right? Over here, which is similar to this one. So I'll just sub in over here also, right? Yes, and then now plus b naught. What is b naught? B naught is simply 1, so I'll just simply sub as 1. And then g is what? Is this one? g1s, alright? Your zeros of your controller. Alright, so it's just g1s plus g naught, which equals to your ACL. So this is your first equation. Alright, right? And if you still remember, we need a second equation for our ACL, where it's somewhat for the fourth order also. Alright, so I need another ACL. Alright, is equals to some s plus a, s plus b, s plus c, s plus d. So all of these are 4 order. Alright, but I need some values for my a, b, and c, d. And in terms of this is why often you will see that in the context. Alright, where is it? Over here. Aha, your complex number comes already. Alright. So this thing over here, don't be scared. It's just simply stating that it's just s plus a. This thing over here is your s plus b, s plus c, and your s plus d. Alright. But because you normally want to design your controller, you need to input a certain frequency, and therefore you're going to talk about your frequencies over here. Alright, these are all your complex numbers. So when you input your parameters for your controller, and then into your system, and then you interact with your functions. Alright, therefore this is somewhat the general equation for you for a complex system. So it's minus, for example, s minus a. Normally they use s minus a, I don't know why. But anyway, because if you write s minus a, is simply taking your pose in the right half plane. Alright, but because anyway, let's continue first. Alright, I'm not going to go into details. But take note that it's some s minus a, where a itself is half minus 1 plus j. Alright, so at this portion over here, as you can see, is minus half minus 1 plus j. Alright, well this part is the conjugate of itself, so it's minus half 1 minus 1 minus j. So you just, so this part over is minus 1 plus minus j, right? So it's being split into two parts. Alright, over here. So far so good, you just take a look lah, okay? Macam only. Same thing over here. This thing over here you split into two conjugates. And therefore they are still fourth order, but in terms of a conjugate system, because they are all 4 poles. You will just take a look. If you just plot it out in your stuff, alright, it's simply like this, alright, in the right half plane. So this is the conjugate for your real axis is equals to 1, and this is for equals to 5. Or in other words, half, not 1, okay, half. Alright, so this two poles over here is for this one. Alright, while this pole over here is for this one. Just to show you that lah. Alright. Then we do a hell lot of stuff, ensuring that you are good in your math and no careless mistakes. And eventually you'll come here. Ta-da! Alright. Instead of writing this equation of 1, I write as equation of 2. And tobalik lah. So they actually write our equation just now as 1. You get what I mean? So this equation 1 now is the one that we found just now. Alright, it's this one. Alright, so this one, if I were to expand, alright, I should get the same thing over here. Alright, so far so good, which is the one that we have found just now lah. This is our equation 1. Alright, if I expand, it becomes like this. And then for the second equation, which is the one that we have just found, using our complex conjugate, you have all these values, and therefore this 11, this 60.5 and 55 corresponds to your H1, H0, G1 and G0. And therefore I can simply write H1 is equals to 11, H0 is equals to 60.5 because it's over here, and then my G1 is equals to 55, which is over here, and 25 is my G0. Then I can simply sub back into my transfer function already. Because of transfer function, maybe I should yeah, these are all the things that written over here already. So at first it was, if you still remember when we started up, is G1s plus G0 over s squared plus h1s plus h0. So we can just simply sub in by our h and g's over here within this system, although this should be small letter. Alright, so this is the same thing. I didn't cheat your feeling. Alright, we started off, we say that we want to know these values over here, G1, G0. So now we have all this value, we just sub in over here and that's it. So this is just some application of a strictly proper system using a strictly proper criteria, and that's all it is. In the next video we'll talk about inclusion of integral. Yeah, see you there.